Hello, I am Amit and we are learning AI and machine learning. So we are going to discuss module 8, that is NLP, Natural Language Processing, Algorithm and the Technique. So first topic is language modeling and the word embedding. Definition: language modeling, predicting the next word in a sentence or understanding the probability of word sequence. For example, predicting the next word in I love to eat dash. So pizza, either pizza, burger, or anything which is related to eat. So that is called language modeling. Then word embedding, representing word as a dense numerical vector so that similar word have a similar vector value. Example: king related to the man, same way woman related to the queen. So our AI model will automatically predict woman is related to queen. Okay, let's understand with example. So example code is word embedding using the Jansen. So from Jansen.model import word to vector. Sentence is like I love NLP, natural language process. NLP is a fun. I love machine learning. Model equal to word to vector sentence. Vector size equal to 50. Window 3. Mean count equal to 1. Get vector for a word. Print model dot wv NLP. Find similar words. Print model wv dot most similar NLP. Let's try to run this code. Okay. So here we get the result. Let's try to understand. So line by line explanation. Import word to vector here. Import word to vector. So you import word to vector class from the Jansen library. Then define training data. We are defining the training data like sentence equal to. These are the list of words. Like I love NLP. NLP is the fun, and I love machine learning. These are the list of words. Each sentence is a list of words. So word to vector use this sentence to learn relationship between words. Then train word to vector model, like model equal to word to vector sentence, vector size 0, window equal to 3, minimum count 1. This create and train a word to vector model. Parameter equal to is vector size is 50. Each word becomes 50 dimensional vector. Window equal to 3 model. Look 3 words before after the context. So mean underscore count equal to 1, including even words that appear once. Get embedding vector of the word. Then print model dot wv NLP. This print a 50 dimension vector for the word NLP. Example 0.2 minus 0.4, 0.8 like this. So these are the 50 dimensional vector that words NLP can be generated. So for each word we have a number like this. For log we have a number like this. So this way it can work. This vector separate the meaning of NLP learned from the context. Think of a word like a personality. If you describe a person using 50 traits like height, weight, confidence, kindness, intelligence, etc. So together all 50 traits describe the person well. Same way 50 number describe a word. Find similar words like print model dot wv dot most similar NLP. This find words whose vector are most similar to the vector of NLP. Example: machine is like 0.87 and learning is like 0.62. Word to vector learn the NLP appear in a similar context and machine and learning. So this is the code that each word is considered as a digit like this. After word to vector, blow fast text introduction. The word to vector based on a neural network produce embedding where similar words cluster together. So from Janssen model, import word to vector, model word to vector sentence vector underscore size equal to 100. Then blow vector for word representation. Use word co-occurrence matrix. Blow is usually load from pre-trained files. Like this, from Janssen model, import keyed vectors. Blow is equal to keyed vector dot load underscore word to vector underscore format. Blow dot 6b dot 100d dot text. Free blow computer. The fast text developed by Facebook worked with sub words unit good for misspelling. From Janssen model dot fast text import fast text. Model go to fast text sentence vector size 50. Read model WB learning. If I run this code, okay. So these are just a format of code. This is not the complete code, but this give us about the idea of like how to use word to vector, globe, and fast text introduction. Sentiment analysis and text classification. So sentiment analysis determines whether text is positive, negative, or neutral. Text classification assign a level such as spam, sport, or a politics, etc. Example code sentiment classification. From text blog import text blog. Text equal to I love learning NLP. Blog equal to text blog text. Print blog sentiment. Let's try this code. So sentiment is polarity is 0.625, subjective equal to 0.6. Or we can use psychic learning to understand this concept more better. Like sentiment analysis, it will give the positive or negative or neutral value. Psychic. We are using psychic library. Okay. So negative sentence, how? See, we have a code like this. Okay, so try to understand this code. From sk learning.feature extract underscore extraction.text import count vectorizer. From sklearn.navy underscore by import multi-nominal nb. Text is like this. I love NLP. I hate this movie. This is bad. I dislike the acting. Amazing movie. Absolutely tribal film. So these are the feedback or some positive or negative sentence. According to this, we define it. This is a positive because I love NLP is a positive. After I hate movie is a negative. Same way negative. Then this is a bad negative. I dislike the acting negative. Amazing movie positive and absolutely travel film negative. So this way, if I write here, NLP is hate. The hate word is for I hate. So this is for negative. That's why it's coming like this. If I change this like amazing, let's try this. Go to the code and change here. NLP is amazing. So it's our model present is a positive. So it's a sentiment analysis. According to the sentiment, they uh, predict the codes and all the things. So it's a positive, negative, and neutral. So sentiment analysis determine whether text is positive, negative, or neutral. All right. Then named entry recognition, that is NER or a POS tagging. This is a part of speech tagging. So definition: NER, named entry recognition, identify name of person, organization, and date, location, etc. And POS tagging, part of speech, identify noun, verb, adjective, etc. Example code: NER or a POS using the spice. Import NLTK from NLTK, import word, tokenize, POS underscore tag, NE underscore chunk. So download required package like kt words, then maxent underscore chunker. So text equal to, let's suppose we are checking like Barack Obama was the 44th president of United States. So it's tokenize the word, tokenize equal to word, tokenize text, POS tagging, token lag equal to ing. So print PO tagging from the word tag in POS. This way we create a code to understand the POS tagging and the NER. Okay, let's try this. Okay. So this is the sentence: Barack Obama was the 44th president of United States. Let's do it. Here. So Barack is NNP, Obama is NNP, then was BBD, the DT, 44 JJ and NP, like this. So named entry recognition is person is Barack and person is Obama, and GP is United States, like this. So this way we can use named entry recognition and POS tagging. So this way we can POS tagging part of a speech. This is noun, this is noun, this is verb, adjective, noun, like this, and name that recognize name entity recognition. Okay. After that, implementing our NLP model definition, building and training model using algorithms such as Navy Bayes, logistic regression, RNN, and LSTM transformer. BERT. So example, simple text classification logistic regression is, these are the codes. So it's train a machine learning model to understand if sentence is positive or negative based on training example you give. So positive, for positive it's 1 and for negative it's 0. Let's try this. So text is like, I love Python, I dislike balls, and Python is a great. So level is 0, 1, 0, 1. 1 is positive, 0 is negative, and 1 is positive. So overall it's a positive. Print, for this I love coding. One minute. See, it's a 1 because I love coding is a positive. So if I change I dislike coding, dislike coding. Still 1 because it's related to this. So it's train a machine learning model to understand if a sentence is positive, that is 1, or negative, that is 0, based on the training example you give. Now let's try to build a real life project, full working code using Python plus TK Intel GUI plus LSTM text generator. So we can create, we are going to create an app like ChatGPT so that they can create a poem. For this, we are going to save a poem in a file, text file. Let's see into the folder here. Name of the file is poem and it's a text file. So I have saved around 5 poems here, and I'm going to use poem underscore generator.gui.py to generate a GUI model. So it's here, poem underscore generate.gui.py. Now I'm going to use this code so that we can develop a user interface where they can create a poem. Okay. For this, we have to store some poem under the text file whose name is poem.text, so that they can learn from that text file and generate the poem relevant. this is our code. Let's try to run this code. So it's processing till 50 times. Okay, training finished. For 50 pods, they trained the model. Here, so we get a user interface where they create a poem. So we have this poem. By referring this poem, our model can create the poem according to this. So let's suppose I'm going to put this word motivational into this and generate poem. So motivational poem. There is again cat. There are like this. Sit, sit, sit. There are play, play, sit. So they try to build a poem like this because we have a very small poem and our model is not so much efficient like the chat GPT, but it's creating something. This way, the chat GPT works so that we can, if I type on chat GPT that here, give me poem on rain. Let's create the poem on rain like this. 2, 3, 4, 5 like this. Because ChatGPT is a very big platform and they have very big data stored and their code are more perfectly retained compared to our code. That's why if we work on this code, we can also develop this kind of uh, chat GPT like platform so that we can create a poem, our model will create. So let's have it with another example. Let's suppose I'm going to put funny poem. So funny poem, my lazy cat, there are, sit, sit, there are, so there's something creating like this. But our model is not so trained and not our code is not so good. If we work on this code, we can also create this kind of platform easily. So this is the model we created. And this is a mini project how a chat GPT can generate a poem or something, a story like this. So if we build some more efficient model, we can also create a poem or a story or something like song, anything. So that is about the complete natural language processing algorithm and the technique. Thanks, uh, thank you so much. So we have completed module 8.